Alright, network programming ITT 440, final chapter, parallel programming in Python. So last chapter 8, we see what is we learn about parallel processing. What is parallel processing? Why we need parallel processing? The motivation of parallel processing and application of parallel processing. Okay. So to do the parallel processing, we need a parallel programming, right? So our content outline for today is thread versus process. Okay. So before we learn about Unix multiprocessing. So the first chapter, our chapter is process, right? Okay. What is process? How Unix process? How to manage? How list down all process in OS, right? And then the second one for chapter content, parallel versus concurrent. Okay, parallel versus concurrent. And last we go to Python. Okay, Python programming, Python parallel programming ecosystem. So our chapter outcome, okay, our lesson outcome. By the end of the lesson, students should be able to understand the basic concept of CPU hyper threading, and students should be able to write parallel programming in Python. Okay, ready? Yeah. First, we look into what is different between thread and process. Okay, thread versus process. Okay, if you notice in this logo, Intel Pentium 4, there are a symbol HT there. Okay, hyper threading. What is hyper threading? Kamu pernah dengar core, Intel Core kan? Dual core, core to duo. Kemudian dia ada i5, i3 semua dah ada core kan? Adakah core tu thread HT? Okay, hyperthreading was Intel's first attempt to bring parallel computation to consumer PCs. It debuted on desktop CPUs with the Pentium 4 HT back in 2002. A single physical CPU core with hyperthreading appears as two logical CPUs to an operating system. Okay, a single physical CPU core. Situ ada core, situ ada core. Maksudnya satu core je. Tapi kalau satu core ada HT, that mean dekat OS akan nampak dia sebagai dua CPU. Right. Kalau ada dua core tanpa HT, dual core without HT, so OS akan nampak sebagai dua CPU kan? Betul kan? Ini satu je, satu core saja, tapi ada HT, so dia akan nampak dua juga. Okay. While the operating system sees two CPUs for each other, the actual CPU hardware only has single set of execution resources for each core. So hyperthreading allows the two logical CPU cores to share physical execution resources. So hyperthreading can help speed your system up, but it is nowhere near as good as having actual additional core. So dia tak sama dengan a real dual core. Okay, walaupun dia nampak sama, dia CPU nampak dua juga. So dia nowhere near as good as having actual additional core. Okay, boleh ni tau. Okay, kalau kata komputer saya lah, kat mana nak tengok task manager, performance. Ada hyperthreading kat sini? Agak-agak ada hyperthreading tak? Okay, saya pakai Intel Core i5. Okay, core saya ada 4 saja. Kan? Kan? Quad core. Okay. Intel i5 ada quad core. Okay. Can you see? Tapi OS saya, Windows akan nampak ada berapa CPU? Ada 8 CPU. Kan? Maksudnya ada HT lah kat situ. Boleh? Boleh faham? Patutnya nampak 4 saja sebab saya ada 4 core kan? kan. So saya ada quad core tapi ada HT, so nampak 8 kat situ. Boleh?
Boleh faham.
Okay. So multiple core pula. Baru nak masuk multiple core. Tadi dia tunjuk contoh quad core kan. So originally CPU had a single core. That mean the physical CPU had a single central processing unit on it. To increase performance, manufacturer add additional cores or central processing unit. Okay, sebelum ni kalau kata tak ada core ni, memang motherboard dulu-dulu motherboard dia boleh letak multiple processor dalam satu motherboard kan. So masa tu bukan guna untuk PC lah. PC personal computer kan. Dia guna untuk enterprise memang untuk mainframe ke workstation ke kan. Dia memang ada motherboard tu boleh masuk multiple processor. Apa nama motherboard server sekarang pun macam tu lah kan. Tapi nak kata dulu tak adalah buat untuk PC kan. Okay. Sekarang dah lah motherboard processor boleh masuk multiple processor. Lepas tu processor pula ada core. Lepas tu processor core pun ada HT pula kan. Berdouble kan. Right. Okay. To increase performance, manufacturer add additional cores or central processing unit. Okay, cost. A dual-core CPU has two central processing units, so it appear to the operating system as two CPUs. Okay, so dia ada dua multiprocessor dan apa nama multiprocessor pula. Microprocessor, M tu bukan microprocessor kan, tapi dia punya chip dia ada satu je. Okay, tu beza dia. A CPU with two cores, for example, could run two different process at the same time. Yang kita dah belajar parallel sebelum ni kan. This speed up your system because your computer can do multiple things at once. So a dual core CPU literally has two central processing unit on the CPU chip. So a quad core CPU has 4 central processing unit and octa core CPU has 8 central processing unit. Okay, core versus hyperthread. So in hyperthreading, the operating system is tricked into sync two CPUs for each actual CPU core. So there are no tricks on multi-core. A dual-core CPU literally has two central processing unit on the CPU chip. So a quad-core CPU has 4 central processing unit and octa-core CPU has 8 central processing unit and so on. Okay, so modern CPU now have both multiple cores and hyperthreading technology. So dual core CPU with hyperthreading appears as 4 core to your operating system. Okay, dual core CPU dengan hyperthreading akan appear 4 core to your operating system. Contoh saya tadi, quad core akan nampak ada 8 kan, ada 8 core kan, tu Windows kan. So hyperthreading is no substitute ni subsyn kan, sorry. Hyperthreading is no substitute for additional cores, but a dual-core CPU with hyperthreading should perform better than a dual-core CPU without hyperthreading. Tu maksud dia lah. So how thread works? So a thread is a unit of execution within a process. A process can have anywhere from just one thread to many threads. Alright. Okay, dalam satu proses ada banyak thread dalam satu masa dia boleh execute. So how process work? So programs are typically stored on disk or in non-volatile memory in a form that can be executed by your computer. So the program has been loaded into computer's memory in binary form, and executing a program needs more than just the binary code that tells the computers what to do. The program needs memory and various operating system resources in order to run. So a process is what we call a program that has been loaded into memory along with all the resources it needs to operate. Okay. Ya ini thread versus proses kan. Thread versus proses. So apa beza dia? Thread lighter weight operation, proses heavy weight operation. Kan dalam proses kan ada banyak thread kan. So proses ada own memory space, kena ingat tu. So thread macam mana? Thread dia pakai memory space yang dekat proses lah kan. Okay, so untuk proses kita ada IPC kan, Inter-Process Communication. So untuk thread inter-thread communication pun ada, tapi dia lebih laju daripada IPC. Alright, so IPC ni normal lah. So inter-thread lagi laju, okay. Untuk proses context switching between process is more expensive. So context switching between threads of the process is expensive. So threads share memory with other threads of the same process, but process don't share memory with other processes. Okay, clear?